All right, let's talk about ions just briefly. And when I do want to look at ions, you will see some symbols that we have just looked at that have a plus, or sometimes you see something like that with a negative there. So you'll be asking yourself, or perhaps you're already asking yourself, what are those? So those are the things that we want to look at. How come we have a plus? How come we have a negative? What is the essence? So what's the explanation behind these charges? These are basically charges, positive and negative charges. How do we get to a point of having these charges? So let's start. An atom is considered a neutral when it does not have any charge. So this, what you see here, sodium, there is no plus, there is no negative, it is neutral, all right? But do you remember the electronic configuration of sodium? Okay, electronic configuration comes from the arrangement of electrons across the different energy levels, and it follows some rules. We have to fill the innermost shell or energy level, and it takes a maximum of 2 electrons, and then the remaining electrons can go to the second, and if we have more, they go to the third. The second and the third can take a maximum of 8. Okay, that's another rule. So let's write the electronic configuration of sodium. It has an atomic number of 11. That is to say, it has 11 protons. Okay. Remember, for a neutral atom, the number of protons equals to the number of electrons. Okay. So it has 11 electrons. So if it has 11 electrons, then we can write the electronic configuration for the 11. It has the first shell, it will take 2, so we'll write 2. Since it has 11, it means if you put the maximum, which is 8, you will still remain with an electron. There. So this is the electronic configuration of sodium. So if we are to draw it, you're saying this is okay, just a minute. This is the nucleus. That is the nucleus. That's the first shell with the 2 electrons. Or you can use dots. And then the other one, those are 2, those are 4, those are 6, and then those are 8. Remaining 1 to make 11. So you have 1 more electron there. So that is the electronic configuration of sodium. Now, we have what we call noble gas configuration. The noble gas configuration is that the outermost shell can have 2 electrons, can have what we call 8 electrons, can have 8 electrons. Helium, for example, has 2 electrons, and it is stable, and it is under what we call the noble gases, or the inert gases, right? So it has that configuration. And then we have argon, it has 8, and neon, it has 8 in the outermost shell. So they are what we call group 8 elements, right? Yes, so those are stable. Now, other elements also want to tend to that stability. They need to get the electronic configuration that has 8 in the outermost shell for them to be stable. Okay, so sodium, for it to be stable, it has to lose this, such that it gains the stable configuration. So it gains the stable configuration. So when sodium loses an electron, which is negatively charged, it means it leaves behind a positive charge. And that's why when you write sodium, you write it like this. I repeat, when an atom loses an electron, it becomes positively charged. When it gains an electron, since if you gain a negative particle, your negativity, you actually become more negatively charged. The particle becomes negatively charged. If it was a neutral atom, if a neutral atom loses an electron, it loses a negative charge, it becomes positively charged. Okay, so that is what happens with sodium, and that's why it has a +1. We can't say, and another thing, we cannot write sodium with a plus, with a 1 here and then a plus. We cannot write it like no. We don't put the 1. That is the notationally or conventionally we don't put the 1. Okay, but we can, for magnesium, we can put that because this is a 2, 3, and 4, whatever it is you can put, but 1 you don't put conventionally. Okay, so when an atom gains electrons, becomes negatively charged, so we call them anions. When an atom loses electrons, becomes positively charged, so we call them cations. Okay? Yeah. So the same thing here illustrated with chlorine. For chlorine to be stable, it is in group 7, right? So for it to be stable, it has to gain 1 more electron, and it becomes negative. Okay? So metals lose electrons. Non-metals, where chlorine is, where you have sulfur, you have nitrogen, these ones, for them, they will have to gain. Metals lose, non-metals gain. Okay, so metals have a positive charge, and the non-metals will have a negative charge. So we call them anions. For metals, we call them metal cations, right? Yes. So the losing, the gain is about having that noble gas configuration. So if this one gains 1, then this will be 8. So it gains the noble gas configuration. Okay? Yes. The same to oxygen. It will gain 2 for it to noble gas configuration. Right? Yes. The same to sodium. Okay? Aluminium. Aluminium, it will have to lose 3 for it to be this. Lose 3 electrons. It is a metal. Lose 3 electrons, become positively charged. Okay, so that marks the end of this presentation where we have looked at the noble gases configuration in relation to creation of anions and cations. Thank you.